now.
Awesome.
So we are live.
Hey,
So
go for it.
welcome everyone. We are now going to be starting our presentation for FRC coding in C++. Before we begin, I would just like to remind everyone that this presentation is being recorded, and as such, the chat and Q&A, or just the Q&A in this session, is going to be monitored during the session, so be sure to utilize your gracious professionalism. Anyways, now that our presenters are ready, we'll go ahead and get started. So without further ado, I'd like to introduce to you Mr. Ed Barker and Mike Riley.
Hello there, I'm Ed Barker. I'm with Cal Robotics. Real quick, I guess you're looking at me. I see CC on the screen.
I can see you, Ed.
Okay. Anyway, my name is Ed Barker. I'm with Cal Robotics, and we have here, introduce yourself, Mike.
Mike Riley. I'm with 4509 Linear High School.
I'm a mentor for Cal Robotics. I've been there for 16. This is my 16th year, and I also work for a company called L3 Harris, and this session is about C++ programming. You're probably wondering why C++, why not Java, why not fill in the blank, Python, Scratch, or whatever. What I'd like to do is just talk for a few minutes about some of the things that I do in the industry and where C++ is used, and sort of give you a reason to learn it. And so we're talking about C++. Let me tell you a little bit first about what we do with it, why. I work for a company called L3 Harris. I'm in the Space and Airborne Systems Division. We do spacecraft, we do aircraft. Back in the old days, if you had an automobile or a train or a plane, it's very analog dials and gauges and mechanical levers and linkages. Now everything is fly-by-wire. Your car is increasingly fly-by-wire. Robots, when you drive your robot across the field, it's fly-by-wire, completely digital communications. There's no cables and linkages or levers that goes out to the field to operate the robot. So we have what's now called the modern digital aircraft. This is an F-35. If you look right here where the pilot is, this, what you would call a dashboard, there's a module there about 4 or 5 inches thick. It's the entire front plane. It's called a PCD, panoramic cockpit display. Right here in this area here is another item. You can't see it, but it's in that area. It's the size of a very large toaster or a small microwave. It's the processing unit. And down here in the belly somewhere, there's another box called an ICP. And on keyboard, this is the PCD here. So this is completely glass cockpit. If you look at any old aircraft, you see lots of dials and gauges. Are all sports cars. Cars are becoming increasingly like this too. And this was designed and made right here in Alpharetta, Georgia. It's just right up the street. That's the computer that sits behind it. It's pretty boring looking. It's made for aircraft and spaceflight standards. This is a computer that's a computer chassis. It's about the length of a robot chassis. It takes about 4 dozen modules. You don't see any electronics here. 4 dozen modules, and every module is a computer itself. So that's a lot of horsepower. You can almost think of this as being a small mini computer, or not mini computer, small supercomputer. Some of you guys and gals may be using what's called CAN bus on your robot. About 2 or 3 years ago, same type of CAN that's on your robot and runs your automobile, is used to run the subway in London. I think it's the subway, and it's now approved for space flight. This is a radiation hard chip. It's CAN bus on the satellite. This is another example of a glass cockpit in a commercial airframe. You'll see there's all sorts of ruggedized displays, buttons and stuff around the edges. That format's very common. Displays, buttons down the edges, and touch screens. This is a very different digital cockpit. This is the Orion spacecraft from Lockheed Martin. If you look inside the spacecraft, you will see very similar looking computing systems, display systems, control systems, a lot of glass cockpit. You're wondering, why is it all touch screen, or why is there so many buttons there? There are people that spend their careers, you can get a PhD in it at Georgia Tech, and it's called human factors interfaces, where they study and optimize the interaction between the person and the machine. So you're trying to optimize your interaction and performance with the machine. And you can get into a lot of debates about what's what. Here's a debate starter. This is the Orion spacecraft here. It's more conventional, modern or digital aircraft. This is the SpaceX thing that went up just a few weeks ago. You'll see that there's no buttons around the edges here. There is some buttons here in the middle and some knobs. Turns out, no matter how hard you try, you still need some buttons and knobs to do things. So SpaceX here on the bottom, Orion here on the top, and Orion is the one that will be going to the moon. So for all of those, let's go back for a second. So for all of these systems here, we use a language almost exclusively C++. There are a couple of other languages that are another language like Boeing uses. C++ is pretty much the go-to language for high reliability, ruggedized, high performance computing languages for automobiles, trains, planes, things that move, robots. And moving on to robots, some of you may have heard of something called ROS, which is Robot Operating System. If you decide to go into robotics, you go to engineering and computer science school, go into robotics, you're going to be dealing with something called ROS. Probably a pretty good chance. And it turns out most of the code it's solid code that you'll deliver will eventually turn into C++, but people do a lot of Python on the platform for prototyping, for testing, and sort of breadboard and ideas. At where I work, we use LabVIEW to run test frames, which talks to Python. Computers running Python, which talks to C++ programs that's actually running on the things that fly. But what flies is C++. Everything else is sort of supporting the task. So I'm going to throw it to Mike here. Let him talk about the slide. Throw under the bus here.
Unmute myself. So, you know, I'm a high school computer science teacher, and so by default I have done Java. I do Java. Prior to teaching, I was actually with a corporate consulting position. Did a lot of Java for federal budgetary systems, like big systems. And so Java has been comfortable for me for robotics. Now, some people would argue, well, C++ is insanely faster and blah, blah, blah. Well, yeah, and it is. To the level of what my team would use, not necessarily. What we're trying to do is make sure we have good, clean code that's reliable, dependable. And there's a good session on Java by Brian Carlson later today, I think. So why that, though? Why C++ instead? Well, first, before we go into what we did, I want to know if my students are going to go into a coder as a software developer versus, say, an engineer for hardware. If engineers for hardware aren't using Java, then I got to help make sure to expose them to what they're going to be doing. As a teacher, it's a responsibility. The second thing is actually a great resume builder. I've heard from every single company that I work with, and we work with some big ones. They want to see your variety. They don't want a one-trick pony. They don't want, well, I know Java. Well, have you tried other things? Have you tried Python? Have you tried anything else? So C++ is a great, meaningful gateway into another language. And then just to go into maybe more about what this presentation, hopefully one thing you get away from is it's hard to learn languages. And, you know, I don't mean to slam WPI, for example, but their resources, these are really smart people who wrote tutorials who might not be dumb enough to write tutorials. They might be too smart to write tutorials. And so they're using first speak in many things, like, and then you do this, then the Talon, and all of a sudden the word Talon comes out of nowhere. And so for a new teacher, a new student, they're like, well, what's a Talon? Is that a Talon SRX? And so it can just go down a bad rabbit hole. So behind this was C++. I want my kids to have comfort in learning a new language. 2, I want other teachers to learn a new language. Most teachers that I work with in Gwinnett County, and I think we're now up to 10 teams, we just added 2 teams, none of us have ever sat by ourselves and coded a robot. We're always doing something. So we thought this is a great opportunity to learn C++ as well. So what you're going to see later on too is some of Ed's tutorials that he videoed, really basic coding, one thing at a time. We also have a basic list of hardware, say these tutorials match this hardware. So if you're going to go buy some motor controllers or buy this or that, buy these things. And these tutorials fit these things. So it's a little bit more than just C++. It's more about how can we learn a language? How can we make another resource that's useful to our teams and to our teachers? there's a bullet point on the screen that says C++ will have a little bit steeper learning curve. Well, yeah, it can be a little bit. We're going to talk about pointers, for example, instead, where Java doesn't have any. But I do think this tutorial set that Ed's created and we've tested has been a very strong effect for our team for various reasons. I think it gives some kids some opportunity to really add some skill sets and some exposure to what they're learning. Because remember, this is all about inspiration. And so this is another way we can inspire kids to do something else.
Okay.
Go ahead.
Yes. One of the things I really want to emphasize here is that, and I've observed this forever, all you guys and gals are very smart. You want to boil the ocean and do everything. You reinvent the whole universe. I get that. Been there, done that. But I can tell you what's really important is that you start with the fundamentals and you learn those fundamentals extremely well, and then build on that and build on that and just keep moving up. And every step of the way every step that you make, you really understand what you've put behind you. So, you're not going to be able to learn C++ today. There's too much to do there. What we will do is give you the tool set so that you can learn what you need to learn very well. And what's really important, I think, in learning computer science or anything, especially computer science, is a giant universe of things to know. There's a million traps of going down rabbit holes, and we'll keep you out of the rabbit holes and focus you on what you need to know how to get these fundamentals. Let me just throw this to Mike for a minute so we can talk about this particular control system.
So once again, I'm a software guy, not necessarily a hardware guy. I've been around the same amount of time as Ed, actually. We started the same year. I started with 1771 and now 4509. But I can tell you, this was the first year that I've actually put together a control system, like literally connected all the wires, things like that. I could tell you what a PDP is and all this other stuff, but I've never put it together. So what you're looking at is on my bench in my basement, a scrap piece of nice birch wood that's kind of semi-framed for a first robotics robot. And we slapped together just a mess of these different components that Ed had made a list of. He and I went back and forth about what should we get. First, we started with the basic control system that is in the kit of parts. And then we talked about just the typical motor controllers and other things that we may have used. For example, in the top right corner, you're going to see there's a Gray Hill encoder attached to a very basic gearbox with a sim and a wheel on it. And to use encoders is an incredibly simple thing to want to be able to use. It's a very good measurable thing. So when we're looking at that, it's like, okay, there are so many encoders on the market. There's the mag encoders from SRX and other things. So every single thing has a difference. So this is just a visual example of, we wanted to standardize a board for all of the teachers in our group that Ed trained to say, okay, so that way he's not saying, well, you have a Gray Hill and you have the SRX and you have this and you have that. Also, motor controllers, well, you've got a Spark and you've got a Talon, you've got a Talon SRX. It's all the same thing, but there's subtleties that can really throw new people and new students, not just teachers, but students. And so when you're fragile in the beginning and you're trying to learn this stuff, that one difference between Talon and Talon SRX can really throw people. Spark versus Spark Max. So when we're looking at this board, we are looking at an attempt to say, okay, here's the parts we want to use, Ed. And if you have some critique, push back. But like I said, it's basically your kit of parts with just a couple of the twists and turns on it. You can see in the middle, there's this little Frankenstein switch going on, just to show what a basic switch is. It's an opening of a circuit. And so this is it. This is all its glory. You don't need anything fancy. The only thing I would add is I would like to put a second gearbox on the other side, and then maybe throw some nice little crappy wheels on the front so I can drive this sucker around a little bit in my basement. So this is the visual foundation of what we tried to do this past summer to use Ed's code tutorials.
Yes, if you look at this board here, like for example, one thing about this board is that you don't see any pneumatics, but you can actually use this setup right here to learn how to program pneumatics and actually see it work, even though there's no pneumatics. And when you go through the tutorials and the exercises, you'll see exactly how that works. You also see, as part of that, a knife switch here, which the reason we use this knife switch is that knife switch is, we use it for several things. One thing is we use it to pretend to be the pressure switch in the control system, and that's important because that switch is sort of a mystery device, but not most, but a lot of people don't know what a switch, what a wall switch or any kind of switch really is. So here you get to physically see how this works. Again, I'm taking you back to, I want you to fundamentally understand between the difference between digital and analog, what a switch does, what an encoder does, how to use them, how to become comfortable, confident, proficient at it. Now, the title of the class says C++. If you're really feeling ambitious, you can do the exercises in C++, and then you can turn right around and recode it again in Java. And I think, Mike, you did that this summer, right?
Yeah, and we're still crafting a couple of them, but yeah, it's very straightforward, very easy to do, especially if you have a Java background, Java experience. And just the other thing about the hardware, just little things, that even Ed and I are still discovering. He taught me, like, you don't need the whole pneumatic set. The pneumatics control module flicks lights that tells you if it's working or not. Like, oh, okay, great. I don't need a whole compressor and everything else set up. I got lights that go on and off. At the same time, I think even Ed learned a little bit more about the Talon SRX abilities. Its encoder system. So for those who are new, he and I combined are over 30 years in this, and we're learning stuff.
Yeah. Created a web page at the Cal Robotics website. If you scroll down, there's an article that says Learn Embedded Programming Using the Control System. And this is probably very hard to see, but basically at the top here you have documents. All the rest of this is videos. Now, what the videos are is you can sit down once you have access to a control system. Actually, some of the videos, the first group of videos, you don't need a control system. You can just study and start working on getting your programming environment setting up. You could actually do the programming exercises short of actually downloading code into a robot or control system. You can learn a lot without the robot. The documents is set up to try and reduce down the amount of information that you need to look if you go off to FRC websites or WPI or anything else. They've had to put every combination of all the Army knives out there. Plus, there's a bunch more stuff on the web, and really kind of head off into the weeds in a hurry. What I'm trying to do here is guide you down this path, such that you learn all the fundamentals very well. You progressively get better at it, and you can sit down and do this on your own. You can do the exercises, then go up to the robot, download the code, drive it around, do whatever you want to do. And you can have a large portion of your team, if they're motivated, to get very good at doing the software in the fall before you even get to the season. Every team in Georgia should be able to do autonomous. There's absolutely no reason why a team can't do autonomous. I don't care what your capability is if you just work through the lessons here. There's one lesson on here, one video I've not yet added yet. It's going to be, because I had to, we lost some parts with the COVID bug out, and I had to order some, which I just got yesterday. But it will be what you might think of as the pure Vex Robotics Talon Victor setup. It uses a set of controls that's a bit different than what you see in WPI Lib. It actually really simplifies your life if you want to be able to do lots of motors hooked together. Like 2 or 3 motors on each side of the robot, where they all sync up and they're doing the right thing, and it makes your programming a lot easier. It's using sort of a methodology on the CAN bus of this leader-follower thing, which is different than the WPI way of doing things. I really like it a lot, and I think you're going to see a lot of that kind of method coming out of our team. It also simplifies other things in the limit switches and reduces errors and all sorts of stuff. That video is coming soon. There's enough here to keep a team busy, an individual busy for 2 months. You just sit down and do a couple of these exercises a week. I'll throw this back to you for a minute. Mike?
Yeah, just to the videos aren't necessarily linear. There's not necessarily a strong sequence, although we've kind of arranged them in a pseudo sequence. But you can kind of jump around a bit. And so if you need to go to, when Ed talked about autonomous, and I can't remember the stat off the top of my head, I'm sure somebody in our crowd could do it, but I think it was something like a third of the people at the short season that we had didn't have autonomous. They didn't roll across a line. And you don't need encoders for that. You can do just a quick timed roll. And some of this will go into that. So you can do it piece by piece. Some of it might seem like, well, I wouldn't use that. I wouldn't use this. It's not necessarily linear. We've found it's fairly easy to jump around. You just have to understand, like, just look at the new code that's being typed in this stuff. Most of the previous code isn't necessarily a required code. So I definitely recommend starting with some of the core essentials. But Ed did some great jobs of just getting you used to using VS Code, which, by the way, same software for those who aren't aware. If you have the FRC VS Code installed, you're set. You don't need more. And so you can just make this new project, and it is a new just-timed robot project where you can make some basic lines and make some basic activities. I find that some of the initial ones you might not think, well, I'm not going to use that. Maybe like the knife switch or something like that. But it does get you comfortable with the code and comfortable with organization, and it does a good job too of organizing your code. I am a big fan of the object-oriented process, and so I know Brian Carlson's going to be doing the Java command-based system, and this is a little bit more towards like a procedural look, one big file versus, say, a robot model. But I do think for those teams that are really just not expert coders, they're just trying to be solid, regular, dependable coders, this is a model that I'm personally embracing. Like I said, this is year 15, 16. Even if you think you've been going along and your team has a history, but you don't have a strong coding team and a coding system for your team, I think this is just something that you might want to take a look at. Ed's right, you can do this right now. If you got a control system, like you saw the board I got out there, if you got a flat piece of something to hold all those electronics, it's a great system to arrange this thing for your coders to have their own little bot to test things with, which many teams have, but you know what? Most teams don't. They tend to have the driving robot that they use and the other one for testing and development, and the coders sit there waiting for their turn. So get your coders aboard, get them a control system. And just for those who are worried about the future evolution of the RoboRio that you might have seen the recent release this week, they've said everything's backwards compatible. Even this, you probably won't see a new system until 2023. So this is not something you want to wait on because of the RoboRio evolution. I think this is going to be a long-term keep for the current RoboRios.
One advantage, like Mike said, you can jump around. If you're new to programming, I'll give you two reasons to not jump around and to do it in order. One is there's a big group of lessons where we've done a lesson, and when we get to the next lesson, we don't just start from scratch, create a project from scratch. We're just adding a feature to the prior lesson. We're just, we're just like building a sandwich. We're just adding the bacon, we're adding the lettuce, we're adding the cheese. It's just layer by layer by layer. So you start out knowing virtually nothing, and when you get done, you got a robot that has encoders that can drive a distance, that can turn to a different angle and go another distance and dance and sing and do all these things. And when you get up to the other end of the pipeline, like, how did we get here? But it's just literally just one step at a time. I'm going to hit it one more time. I can't overemphasize how important it is to understand the fundamentals. It will pay you great benefits in your career. I mean, just a simple knife switch example. So many times you'll see somebody trying to debug something, and I'll just hand this to you. So here, just take this thing, plug it into the RoboRio digital input, and just put the wires together. You don't need a knife switch, just put the wires together. You can test your code. Because so many times when students, especially under pressure and in competition, they're chasing down some other rabbit hole, they have a fault with the problem. So if they learn your fundamentals, you can solve a problem in a hurry. Mr. Moderator, do we have any, we'd like to invite any questions or things we'd like to talk about from the audience. If Mr. Moderator can just forward that to us or get it to us somehow.
And Stephen, you can show yourself if you want to.
I'm not sure how that works.
Sounds good. So anyone that wants to ask questions about the presentation, bottom right, there should be a Q&A section where you can type your question and submit it. You might have been sending it privately. You might have been just sending it. So far, I see nothing, so I don't think anything has been asked as of yet.
And you can just read us the question if you get something sounds interesting there.
Yeah, feel free to interrupt and jump in. Of course,
Sounds
for our
good.
audience, is it just me or Stephen very much have a Kylo Renner thing going on right now? Which is a compliment. There we go.
We got one.
Ava, thanks for that question. So I can see it. Can you see it, Ed or Stephen? I assume Stephen can see everything.
Yes, I see it.
So the question, if the audience can't see it, so we got some questions coming in, so I'll just kind of read them, Ed.
Okay.
So how do you recommend teaching C++ programming for FRC during the social distancing era? So I guess I'll just get that first from the classroom perspectives. Teaching C++ for FRC, I am lucky enough that I am back in my building, and so I have access to a robot, and anybody has access to a robot. So I would personally, and what we're going to do, we're going to be looking at making sure kids have their development system set up, their IDE, the whole environment. The next up is, there's no reason they can't just share code with me in some fashion. They can have their own GitHub branch. They could send me just a download. And I could load their code, Zoom call that, so they can just drive that sucker around. Well, they can't drive around, but they can see me test their functionality with a robot. And if you even get a robot to somebody's basement, they can be anybody on your team. And if they can then stream that test and talk through it, that's where I'm going to be going with it. Slow and steady throughout that. But Ed, anything else you want to add to teaching C++ during the pandemic?
Yes. Couple of things here on the website. I want to add in some links to 2 or 3 websites that are just out there that's used for teaching computer science for self-motivated students who want to just do this online during the pandemic. I guess I got to throw a joke in here first. I just saw it yesterday. Panda bears sit around eating 16, 20 hours a day, that's why they're fat. And so now that we have this pandemic going on, we just sit around and eat 16, 20 hours a day, which is why we're getting fat. So that's why they call it the pandemic. Okay, we go to the website here under documents. I made something called Thin Setup Guide for C++ Programming. Why did I call it thin? It's because you look at C standards and any language standards and any language learning things, it's just a giant, giant, giant universe. Okay, we're doing the Cliff Notes version of programming. It turns out the Cliff Notes version of programming, you can get about 98% done of what you want to get done right out of the gate. And if you think for 2 minutes, you can probably get the other 2% done too. So I'm just going to click on this document here. And actually, I'm on the wrong document. It's a different document, which is Thin C++ reference. That's it. This is the language stuff.
It's very thin.
Yeah, it's very thin. I talk about the things that you would like to know about assignment, variables, iteration, return values, stuff like this. This may seem a little bit intimidating, but learn that well. All the rest will come when you go to college or whenever you do something else. This is stuff that I don't care what you do, any kind of programming career, engineering career, you got to nail this stuff. So the reason I put this guide together is to steer you away from all the complexity and confusion of what you're going to find on the internet. What I do have to do in the next 48 hours is post links to a couple of websites where you actually get to practice the code. Some very good websites. You just type little 5-line programs, 10-line programs. You can run it online and get a result. That way you can see that you understand the principles that are in the thin reference guide. I think that might be what we're looking for. You got another question?
Yeah, we got a couple. So just the next one kind of addresses a little bit what you talked about, what fields is C++ most commonly used in. And so Ed talked a lot about, well, he is writing the control system for the F-35. So it's definitely in heavy, intense, smart machinery. It's in space. I know my field, I'm more of a software guy. most of your first-person shooters and all that kind of world, that's C++ and an Unreal Engine. While other things are good, I do Unity with C# and I've done Java and others as well. If you want performance, generally you're going to be leaning towards C++ in almost any field. But I know for me, video game field as well as middleware, for some of your heavy-duty cluster servers in the massive server world, is C++ for the middleware, the stuff you'll never see as a user. But Ed, if you want to talk any more about the hardware side of it as well.
Yeah, I do want to squelch something a little bit. I'm actually not writing the flight software. What we have here, for those of you that are familiar with the WPI lib control system, you got a Linux computer, and it's got a piece of code on it called the HAL and the WPI lib, that piece of code. And then you write your code that goes on top of that. We have people that do everything up from the Linux to that whole sort of WPI lib version for the F-35 and the other aircraft. And our customer, Lockheed Martin, comes in and puts their code on top of that, which is kind of like what you do on the robot. I write code that aggressively grinds up our version of WPI lib. I'm doing everything I can to break it. I'm actually running code on the flight hardware to break the aircraft. So my code doesn't fly, but the code that I'm calling right under me is what actually flies. Just so nobody thinks I'm writing nobody thinks I'm actually flying here. Other applications that you're going to see, I mean, you see C++ everywhere. Operating systems, Linux operating system itself, the applications, the anything that moves in any sort of big way, autonomous cars, lawnmowers, airplanes, ships. You know, the boundaries between things that you fly or drive and the things that robots fly and drive are getting really fuzzy now. I mean, literally, you can just crawl in the aircraft and let it fly itself. Now we're looking at autonomous cars. Question?
I think that's a strong answer to it. I'm just going to keep some other questions coming. So one is, why is C++ considered the best language for FRC? And I don't know if you guys see the question, but no, to misspell language is kind of funny. It's not necessarily. To me, the best language is the one that you know how to use and use well when you're talking about the best language for FRC. It's, just to tie it to a follow-up question, there's right behind that is the question was difference in performance between Java and C++, and how much does that affect FRC? Trust me, you can go on Chief Delphi and other places and see tons of changes on that. By the way, everything looks frozen to me, so I'm not sure if you guys are hearing me, so I'm going to stop talking.
I can hear you. I can hear you okay. Fine.
So we might be visually frozen. So C++ could be the best if it's what your team does well. Java could be the best if your team does well. My biggest point that I want to make is I think our students need exposure to multiple languages for more of their opportunities. And I think I'm just doing a disservice to my students to get into the hardware world, like the F-35 world and the space world, and I'm not covering or giving them the opportunity to do C++. My team is actually two different coding teams. Some are trying the C++ and some are trying the Java, and you can easily swap code out fast. So I'm lucky enough to have about 4 to 6 coders at any one time. And so as long as they respect each other in systems and don't change the talent IDs on each other, that kind of stuff, we can have competing teams, a friendly competition between the two, as long as the robot works best.
Yeah, the question is a little bit like, you know, what's the best musical instrument to play in a band? I mean, what's the best musical instrument? Well, it depends what role you're trying to play. You know, like in our environment, like I mentioned before, in our development environment, we use different languages to do different roles, different things. For your level of programming in high school, and actually probably a lot of stuff after that, there's not a whole lot of difference between, there's nothing really for you to worry about between Java and C++. It's just you're kind of on a springboard here, getting ready to launch off into something. What's really important is that you understand what you're doing and understand it well. If you want to eventually go toward a career like kind of what I'm doing, where you're making machines move, whether it's autonomous vehicles or boats or whatever, or robots, I would suggest maybe you might want to start off in more of a C++ direction. But again, at the high school level, it just really doesn't make any difference. The WPI libraries are the same. You're not going to see any real difference in performance if you've written your code even 10% correctly. Because the FRC does not have that much performance requirements. Video can get a little more aggressive, but I hope that answered your question. Got another question here?
Yeah, and just one other little note about performance. Is there technical performance differences? Yes, but there's also subtleties in the languages. C++ has pointers, whereas Java doesn't really technically have pointers, where you want to literally change a place in memory. So Java shields you from that, or at least gives you layers so you don't have to do it. There's a question, what are some things I can do to improve on my C++ programming? And great question, depends on your starting point. These tutorials were written for the person with no C++ experience. So as for improving, that's the improvement I'm going from, is I'm trying to critique this from a brand new teacher or student or team trying to code, and let's use C++ to do that. Or take my team and say, okay, let's try and transition to a language. So if you already know some, and to improve your C++, I'll let Ed have that because he lives that world more than I do.
Yeah, I'm not sure that I'd want to inflict some of the things that I have to do in my career. I remember years ago I was reading about the Beatles, and one of the reasons the Beatles got so really good is they had to play in a club for 9 hours a day, 7 days a week, so they had to learn to get tired or they're going to lose their job. When you actually start working professionally and you have a certain standard you got to work to, boy, it can get really aggressive. And we obviously work to life safety standards, because you go to the Hartsfield Airport, get on a plane, you want to make sure you have a nice, happy flight. So we turn on massive amounts of compiler flags and do all sorts of aggressive measures to do everything we can to break code and make sure it's really tight. And for somebody that's not used to it, it's really annoying. I wouldn't want to inflict all this on a high school student. The FRC framework might not be the place to get that tight. Get really good. When I was your age, I was reading some books on software engineering, and well, that's a good question. You kind of stumped me a little bit. You need to have good work habits, that's for sure. You need to really think about how you're naming variables. Just like, again, start with the basics. Variable shouldn't be A, B, C, D, E, J, and K. It should be some meaningful word. And we're actually not allowed to use things. Our variable names have to be obviously meaningful. It has to be well laid out. There are actually coding standards. Learning coding standards would probably be a good thing to do. Learn how proper standards-based variable names are done in industry. According to say, I can't remember the guy's name, but there's some very good standard. There is a C++ standard, how you name every variable and every procedure. If you just learn that kind of stuff right out of the gate, you're going to be a lot more attractive to hiring and having internships in college and hiring after college, because you don't have to break all your bad habits and start completely over.
And just to kind of reinforce on what Ed's saying, so prior to my teaching career, I was part of a team where I think, I'm ballparking these numbers here, we had about 50 Java developers, 20 C++ers, and 20 or 30 database folks making one software. And two things about that is following the standards of the team is critical. For clarity, in variables, in commenting, and a lot of systems, when you get to the larger teams, they'll have check-in, check-out systems that require commenting in certain ways. They'll track everything you did. But the other thing is humility. It's okay to admit when you don't know something. My rule of thumb was I give myself a certain limit of time. So say a work day is, let's just call it 10 hours. If I was stuck for more than an hour or two, I had to ask somebody. maybe even faster than that at times, but so many times our ego gets in the way. And luckily, more things like pair programming and group dynamics of coding have really loosened that up. But there used to be a real ego with, well, I can't show what I don't know. Show what you don't know. Trust me, after a time, if you don't know a lot, they'll let you go. But they're actually going to applaud your courage to discuss versus wait and delay. There's going to be some people that are great at code and they're not really good at social skills. And so they love those troubleshooting problems. And some of you actually might discover too, maybe you're really good at code, but you're actually really good at people skills. And so those business analysts are actually really important to understand the technology, but to also be able to talk to the customer about their real needs and interpret that for the team. So just find your place with code. You might not all be the uber software architect geekum of all time. You might have some other branch role with that. So just be patient with yourselves with code. Find your place.
Now that I've had a minute to think about it and listen to Mike talk some, back to your question about how can you improve your skills? I think if you do what I have to do in my daily work, that would be pretty good. So in our environment, every piece of code, for example, if I write a piece of code and I get it to a certain point, I have to post it for review. There will be about 10 of my peers that get to review it and comment on it. And then we have to have a meeting about it and go over it. And so right out of the gate, you need to have, if you don't know something, you put the note in there and says, I don't know how to do this, or I did this. And you talk about humility. Yeah, there is just, you just got to get your ego out of the way of this thing. It's like, our goal here is to get really good code out that's perfect. Peer reviews, and the one thing about peer reviews is that not only you have other people looking over your shoulder, they can help you when you need help. And when you're reviewing somebody else's code, guess what? You actually get to learn something that the other person knew that I didn't. So it's just sort of a group kumbaya, and it's very productive in the end, but you just got to get your and I would really encourage high school students, if you got like a dozen programmers, maybe you do peer programming, break up into 6 groups, have them work on these lessons and perfect it, and then do peer review and share information. That would probably be one of the most, that and coding standards, and I'll post coding standards out on the site, or standards for that. If you learn how to do coding standards, if you come into a job interview in a place like I'm at, you will have a very different kind of positive conversation.
Any other questions out there to throw at us? I don't know if anybody else is seeing any video. Mine's frozen, but we can hear each other.
I see our host, I see myself, and that's all I see.
Yeah, but you don't see yourself moving, do you?
No.
Okay.
Any more questions?
We're not required to go the full hour.
Yeah.
Definitely want to support you folks. Ed, just did you have the link already on the Cal Robotics site for the parts, for the board parts?
In the next 48 hours, I need to do a link for the parts. I need to do a link for some programming tutorial sites and a link for, what did I say, coding standards.
So the board you folks saw, it has a control system, which your basic control system, you're going to run, let's just call it $1,000. You're going to need another like $400 or $500 on top of that for that board, but you might have some of those lying around. For example, a Talon SRX is about $90, and I had those lying around, so I don't need to buy a Talon SRX as well as a sim, and so on and so forth. So you might only need to add, some of the stuff is like a $5 item or a $10 item if you want to follow the Ed tutorials. So once he gets that out, I believe it's a Google Sheet with links to the products. Some of them too, he made some links to some really handy products. Different connectors and stuff like that are going to speed you up and save you from some electrical shortage as well. Little things we learned about that are nice and neat and organized. So you don't need all of it. Some of these things come in sets that he linked, like there might be a 10-pack where you might need 2 things, but they're going to be handy to have around for the long term. So as you go through this fall season, I've done this for a long time, so I cannot recommend this more. You can have a coding team ready to go for kickoff, and it's a weird kickoff, but they can be ready to go for kickoff and be ready to implement code as the robot is built. They'll be waiting on the robot versus the robot taking turns and giving a turn to the coders. You're going to be reversing the timeline in a sense, which I find to be really exciting.
Yeah, it is really cool to be able to flip that around and just have programmers waiting on robots, which is something that happened to my team all this year. We're just, unfortunately, we got some other robots we could run code on, but we're always waiting on them. My first year, we didn't get the programmed robot till like the last day of the season.
Mm-hmm.
Really, really awful. Back to the question about becoming a good programmer. We're talking about peer review, talking about humility. I do want to bring up one of the things. When I went through the interview for this job, I went through 5 rounds of interviews, and I had questions that I'd never had before in a job interview, which really had to do with ethics and pressure and delivery. And if you're working on a project and it's behind and you're not getting it done, or some other issue, what are you going to do about it? And it's due in a week. You just kind of hide somewhere and crumble up, or you actually go talk to the boss. You really got to just put your ego aside and say, man, this is not working. I don't know what's going on. I need some help, whatever. Just learn that. It's an easy lesson to learn. You get comfortable with it. You're just so much more productive for your team and your individual group as a programmer and engineer. What do you think, Mike?
Well, I'm just hoping for questions, but if people don't have any more, then we can close up shop and stop the recording. Hopefully this recorded something.
Yes.
And we'll find out if there's going to be posting of these things. I think these are going to be posted on YouTube. We could probably add some links to the YouTube once it's out.
Right. I would say just keep monitoring the C++ webpage at the Cal Robotics website. There'll be additional links and documents. There are the thin reference guide to C++. You want to jump into that. You don't want to jump into other external training sessions. There are some videos you can start watching just on some basic components and architecture of control system, Boolean logic, some other things like this, learn some historical things too. And with that, I think that's about all I got to say.
Me too. All right, Mr. Steven, I think we're going to close up shop.
All right. Sounds good. Well, this was a very informative presentation, and as we go ahead and wrap up, just wanted to go ahead and remind everyone, all of our 45 participants, that you can enter your next session by going to the Georgia First Symposium page that you got through the email you received from Eventbrite. I'll go ahead and thank our presenters, Mr. Ed Barker and Mike Riley again. Thank you to the attendees for coming, and have a good rest of your day. I'll go ahead and close this session in a couple minutes as you guys are exiting.
Yeah.
Thanks for your help, Stephen.
Yeah, thank you.